What is up, YouTube? Welcome to another episode of How to Algebra. In this video, I will show you a couple of examples with compound interest and using the function e. So if you haven't done so already, subscribe, smash the like button, comment, and let me know what you guys think. All right, let's get it. All right, man. Compound interest and using e. Simply put, compound interest is basically interest on top of interest, right? Interest that is earned on something that's already earned interest. So if you think about it, if you invest $1 at 5%, right, that means you'll get a nickel. And then if you earn interest again on that, you would have to calculate $1.05, which would be slightly more than a nickel. And then that would earn interest, and then that would earn interest, and you would keep doing that multiple times. So again, it's simply put, it's interest on top of interest that's already earned interest, basically. But that's not really the purpose of the video, explaining what it is. Let's get into how to calculate it, right? That's more useful, I think. So the formula that you're going to see is this guy right here. A equals P times 1 plus R over N and to the NT power. So the idea, there's 5 variables. So you're going to be needed to be given 4 of these variables. That's the only way you're going to figure out the 5th one. If you're missing more than 1 variable, if you're missing 2 variables, you'll never be able to calculate this thing. So A, right, that's some future value. P is some starting value, beginning value, or initial value, or principal. These are all words that you'll see in these word problems. But just know that it's a beginning value that you start with, and then you solve typically for some future value. Or vice versa. You could be given the future value, and you need to figure out what did you start with. R is the rate, and it's going to be usually given as a percentage, and you have to convert it to a decimal. And then the number of times it's compounded, basically, there's a list of vocabulary words which we'll go over, but that's your N value. And then T is typically in years. So here is what I just said. All right, so a quick exploration. Feel free to pause the video and work these out for yourself. Okay, however, I'll just go ahead and give these to you. So what's happening is that you're going to hear or read these words on the left and in the left column. And these are your clues to what N value you're going to use, right? Annually, once, 1, semi-annually, N equals 2, quarterly, 4 quarters in a year, so N equals 4, monthly, there's 12 months in a year, daily, 365 days in a year, hourly, 8,760 hours in a year, and by the minute, 525,600. So depending on what the problem states, you will use one of these values for N, right? It's not going to come out and tell you used N as 12. It's going to say some amount is compounded monthly, and then you have to deduce that it's 12, right? Okay. The formula, the thing that's changing is N. So as N gets larger, or not larger, but as we calculate different values for N, we will get, so what this first one is saying is if you invested $1,000 at 10%, so 1,000 is your starting value, so this is P, 10% is your R, and we need to convert it to a decimal. So to convert percents to decimals so that we can handle them in calculations, you move the decimal to the left 2 places. So 0.10 or simply 0.1. Okay, let's start knocking this out. So this is saying that if it's compounded annually, 1 time per year, you would earn $100. If it's compounded twice a year, it would be $1,102.50. Quarterly, right? The same problem. $1,105.17. And then you could keep this going. You would keep switching out or substituting out your end value for the next end value, right? Okay. Here's the list. It's kind of interesting, actually. The way compound interest works. Okay, let's see some actual examples. Let's apply it. Okay, Ben deposits $500 in his savings account. So that's my starting amount. The account pays 7%. So this is going to be R, which is 0.07. And it's compounded quarterly. So this is N, and it's 4. And then how much money will Ben have in 3 years? So T is 3. So notice, of the 5 variables, we have 4 of them. And we just do the setup, right? A is going to be equal 500, 1 plus 0.07 over N times T, or raised to N times T, which is 3. Straight to the calculator. Straight to the calculator. So we see that the money that he would earn, Ben, $615.72. So notice we had a starting amount and then all the criteria that they gave us, or all the details, and you just fill in the formula. Okay. Number 2 is going to be slightly different for number 2. So how much would you have to invest? So this is saying we don't know what we're starting with, right? We need to figure out what amount do we start with if we want to eventually have 20,000 after 6 years. So T, in an account earning 8.5% compounded monthly. So A is 20,000. P, we don't know. That's what we're looking for. The rate is 0.085. N is 12. And T is going to be 6 years. All right. Compounded monthly, 12 and then 6 years. So the setup, the future amount, 20,000, equals the starting amount, 1 plus 0.085 over 12 raised to 12 times 6. Okay, so we are in the age of calculators. So if you try to type this in the calculator, it's not going to know that you want to solve for P. So there are a couple of different ways you could do this. Right now, since we're just starting out, since we want to isolate P, right, and P is being multiplied times an expression, we can divide both sides by the right-hand expression. And it cancels on the right. So I know that the Inspire has fancy built-in gadgets and buttons that you could just easily just type this in and solve it. You know, I get that. But I feel that it's worth more knowing how it's doing it, right? So most people wouldn't think to divide the right hand side by everything. I'm all about letting the calculator do the heavy lifting 100%. But you do need to know how to set the problem up. So what's going to go in the calculator is going to be the left hand side, right? This needs to go in the calculator because this will tell you what P is. And we see that P is going to be $12,031.52. That's how much you would have to invest to earn $20,000 in 6 years on an account that's monthly compounded and earning 8.5% interest. Okay. So those are the two values. So those are the two examples, right? Either you're looking for the future amount or you're given the future amount and you need to figure out the beginning amount. These are the two scenario types that you're going to get. Okay. When you're talking about compound interest, it's only natural that we talk about the variable E. So E, hundreds of years ago, was discovered by one of the Bernoulli brothers. And he knew that it existed, that E existed. But I don't think he knew the exact value. But he knew that there was some value. And then it wasn't until Leonard Euler, a buddy of Jacob Bernoulli, calculated the number. I want to say like 16 digits, decimals. But if you put this in a calculator, a variation of the compound interest formula, 1 plus 1 over n to the n, and you let n equal 10, and you start increasing 10 by a factor of 10. So 10, 100, 1,000, 10,000, 100,000, and so forth. If you keep doing that, the values will actually start approaching the values of E. So feel free to pause the video and work this out, and I'll just give them to you. Okay, and as n continues to increase, we get again closer to the value of E. So when you're using the calculator, if you're using the Inspire, don't use E down in the keyboard, right? The calculator doesn't know what you're trying to do. There is a function button, E to the X, right? That's 2 left of the 1 button, and that's the one that you want to use. If you do E to the first power, you would see that the calculator gives you this value here. And how does it compare with the last value from the table above? I mean, it's close. It's very close, up to about 9 or 10 digits. It's close. So yeah, so that's E. Again, courtesy of Leonard Euler, hence the E in his last name. That's a symbol that we use. Okay, let's see some properties of E without using a calculator. Okay, so treat E like a variable. It's like pi. It's an irrational number. It goes on forever. But you can treat it like any other variable, x or y or whatever letter, and the exponent properties will behave as normal. So when you're multiplying common bases, you add the exponents. So e to the 7th, right? Because 5 plus 2. 12 e to the 4th over 3 e to the 3rd. We can simplify. 12 over 3 is 4. And because we have a variable in the top, variable in the bottom, it's always top minus bottom. So e to the 4th minus 3. And this is going to be 4e to the first power, or simply 4e. Right? It's implied, it's understood that there's a 1 if you don't put anything. Okay. Number 3. 5e to the negative 3x squared. So because the part inside the parentheses is being squared, we can apply the square to the coefficient and to the variable e. So this is going to be 5 squared. And then e negative 3x squared. So when you have a power to a power, you multiply. This would be negative 6x. So I think we can simplify one more time. Right? 5 squared is 25. E to negative 6x. All right. If you want to match maybe an answer key or the back of a book answer, or even more simplified, like a lot of people would argue that this is simple, except we're taught that we don't like negative exponents. I think E is the one exception where negative exponents is accepted. But if you want to be, I guess, 100% simplified, we could move E to the denominator. Could if you want to. I'm cool with just leaving it here. Okay. The next word we want to add to our vocabulary, our repertoire of mathematical words, is compounded continuously. So in the last examples, we had a list: annual, semi-annual, quarterly, monthly, hourly. So when you see continuously, when something's compounded continuously, there's in fact a whole nother formula that we're going to use. And it's actually a lot simpler. A is still the future amount. P is the beginning amount. E is just E. R is the rate. T is time, typically in years. Okay, so let's see a couple more examples. Terry deposits $100. So this is my beginning amount. It's on his 5th birthday, and the account compounds continuously. Right, there's that word. So I know I'm going to use the alternate compound interest formula. And at 5%, so this is my R, which is basically 0.05. 0.05. Today is his 21st birthday, and he wants to withdraw the money. Okay. There's 16 years that goes from the 5th birthday to the 21st birthday. So 21. So this is going to be A is equal to 100 E to the 0.05 times 21. No, it should be 16. I said 16. I don't know why I put 21. Times 16. Okay, go to our calculator. He would have $222.55. All right, the last example. All right, suppose you invest $1,500. So again, this is my starting value. At an annual interest rate of 9.5, so R is going to be 0.095. Compounded continuously. So I know it's going to be APERT. P-E-R-T. How much we have after 5 years? So T is equal to 5. And then how much we have after 25 years? T is equal to 25. So first off, if we do 5 years, we would get $2,412.02. 25 years. So the same thing, except instead of 5, we're doing 25. This is 16,126.52. Okay. And that concludes compound interest and using E. All right, as always, subscribe. Let me know what you think. Like, comment. I do like hearing from you guys. So I'll catch you in the next video. Peace.